Hi guys, how are you? How are you? How are you? Am I audible, guys? Am I audible as well as visible? Hello, my name is Prashant Jain, All India Rank 42, JEE 2008, BTech IIT Bombay, author of 19 plus books, most viewed IOQM educator since last 4 years, mentor of AIR 1, 6 and 22 in ISI B Math. Am I audible, guys? Let me open it. Let me see your chats. Yes. Perfect. So today is a very interesting lecture because this lecture will form the basics of number system. In fact, number theory. What we have done till now, we have done basic number system, which is available in NCERT also. And we have taken it to another level so that all of us can have a very good base. Now that our base is ready, we have done like factors, in fact we have done cyclicity and some divisibility rules, basic things we have done. Now I am going to start with Euclid division lemma and basics of congruence. But before that, this is my Telegram channel. If you have not subscribed to it till now, please do it. Secondly, this is Ramanujan batch and we have slashed the price to 12,500. The class mode will be Zoom classes and it is Tuesday, Thursday, Saturday. If you want to take the subscription, go and take the subscription of Olympiad Gold. Use code PJLive. 8, 9, 10 we are offering Foundation Centers live program as well, in which our center educators will teach you through Zoom classes. This is a very amazing offering. This can be compared with any offline coaching in which you spend around 40 to 50,000, but here you are getting the same quality at 12,500. For this also you have to take 1 year subscription of Olympiad Gold. If you take Iconic subscription, 1 year Iconic subscription, it will cost you 17,500. But let's assume that you are in class 9th. Then what will happen? You get subscription of 9th class, which means you get physics, chemistry, maths, bio, mental ability classes. Along with that, you will also get Ramanujan classes. So your IOQM is sorted, your foundation is sorted. And you all know that early start is not an option anymore. It is a compulsion to get top rank in JEE, right? So all the learners who are looking out for something related to foundation should definitely check out this course, right? Perfect. So let's get going, guys. I think we can start. So see, what is Euclid division lemma? Euclid division lemma is a very fancy name, right? We call it Euclid division lemma. It's a very fancy name but has a very simple statement. Okay. So the simple statement is for a given divisor and dividend we have unique quotient and remainder provided that remainder is greater than 0 and less than divisor, right? So basically what does this mean? That let's take dividend is equal to 42, divisor as let's take 5. Then 42 can be represented using a unique combination of quotient, that is 8, and remainder. And what you have to make sure, remainder is always between 0 and n minus 1, where n is divisor. So my remainder is greater than equal to 0, less than equal to n minus 1, right? N is divisor, and obviously whatever I am defining is for natural numbers, right? Whatever I am designing is for natural numbers. Whenever the remainder is asked, remainder, see, like, we will not overcomplicate it. You have known the meaning of remainder from your childhood. Somebody will say that, sir, our childhood is still going on. But since you are studying for examination, complicated examination like IOQM, I think you have decided to take challenges in life, and only a non-child can take such serious challenges. So you have already grown up. You have already grown up, and that is why it is safe to assume that you know that remainders are between 0 to n minus 1. Am I making sense, guys? Am I making sense? Am I making sense? Am I making sense, guys? Perfect. Perfect. So, see, this is the statement. And some would argue that, sir, and based on Euclid division lemma, we define all the things, right? Right? Please write UDAN so that I can move to the next slide. Based on Euclid division lemma, we'll define many things. We'll define many things. Based on Euclid division lemma, we will define many things. Please write UDAN. Perfect. Right? So, some application of EDL. It sounds like idiot, but it is not idiot. It's a very important concept. I don't know why NCERT removed it. It's a very, very important concept, especially for JEE aspirants. Some application of EDL. Any number which leaves R as remainder upon division by D, or let's say N, can be represented in the form NQ plus R. For example, if 7 is divisor, then 5, 12, 19, 26 are of the form 7q plus 5. So sometimes we are required to prove some things. For example, if I have to prove something for odd numbers, then I cannot verify it for every single odd numbers. There are infinite odd numbers, right? 1, 3, 5, 7. There are infinite odd numbers. So if somehow I have a representation for odd numbers, what is a representation for odd numbers? 2k plus 1. Every odd number can be represented in the form of 2k plus 1. If I take this general value and if I prove something for that, then I do not have to prove for every single odd number, because I have proved it for the general form. And that is why having this general form helps. Do you get it? Do you get it? Are you able to get it, guys? This is a very important thing, in fact. Right? Perfect. Right? So, if you have understood it, please give me, if 11 is divisor, what is the general form? What is the general form of 4, 26, 50, 48, sorry, 70, etc. What is the general form? See, like general form will always be dependent on divisor. What is the divisor that you are taking? What is the divisor that you are taking? It will be dependent on that. 4, 26, 48, 70, etc. People are saying 11 q plus 4. What do you mean by 11 q plus 4? All these numbers upon division by 11 leaves 4 as remainder. All these numbers upon division by 11 leaves 4 as remainder. Getting my point? Getting my point? Damn. So like Yash gave the answer so fast that somebody was writing, Yash, did you predicted it? Obviously it was not predicting, it was not prediction. He knows the basics, so he was able to answer very fast. Getting my point? Right? Perfect. So another point, any number can have multiple EDL representation based on the divisor, right? Based on divisor, it can have multiple representation. For example, 42 is 5q plus 2, 4q plus 2. See, like it is leaving the same remainder upon division by 5, upon division by 2. But it is of the type 6q, it is of the type 7q, it is of the type 9q plus 6, right? 10q plus 2, 11q plus 9, etc. Getting my point? It has different representation if you change the remainder. With some remainders, it is giving the same remainder. For example, for 5, for 4, for 10, it is giving the same remainder. But largely, it gives different remainders, right? And then one very simple point, if the remainder is 0, then that particular number is, then the particular divisor is factor of the number, right? For example, 6 and 7 are factors, or you can call them divisors of 42. You can see it, the remainder is 0, right? This is a C line. What I'm trying to do here is, you know the definition of factor, you know what is a divisor. I'm simply relating the concept of Euclid division lemma with the known concepts which you know already, okay? And like we discussed it in divisibility also, what is the meaning of divisor, what is the meaning of factor, right? So what we are trying to do here is to relate each and every known thing with Euclid division lemma. Okay, please note it down and write UDAN. Sir, I got your book pre-RMO, can I read? It depends on your English skills. It is written in English. If you can read it, you can read it. Right, right, guys. Perfect. Perfect. right? This is one important concept. Now how it is used, this is the question. Prove that all perfect squares are of the type first 4k plus 1, 5k plus 1, 5k plus 2, right? Please do it. Please do it, guys. Please do it. Please do these both these questions, right? Now you are proving, see, like your proving has to be backed. So what is the ideal? See, like this is something which you will require for RMO also. If you remember, for this year's RMO, we did a question using Euclid division lemma. So for first, what you are going to write, let the number be 2k, 2q or 2q plus 1. Then you take case 1. Now again, you see, like this is a very common question among learners. Sir, how do you design, how do you select the divisor, right? Because the divisor is your choice, right? Divisor is your choice. So it is typically dependent on the question. So here 4k, 4. So what is the prime divisor of 4? 2. In this case, we'll take the divisor to be 5. So let's solve the first one. Now, every natural number can be represented as 2q or 2q plus 1, right? Right? Any number you can think of. Either it is even or it is odd. Am I making sense? This is perfect square of a natural number. Let's assume that the question which is being asked is for squares, perfect square. So let's write 1, 4, 9, 16, 25, 36. Now, a square of even number will be divisible by 4. So this is sorted. This is very easy to see. But it is a very interesting thing that all odd numbers leave 1 as remainder upon division by 4. Now, it is not something which is observational. It has a proof also. So, let's take n is equal to 2q. If you square it, you get 4 times q square, which implies 4 divides n square. So this is hence proof for first case. Now case 2, simply take n is equal to 2q plus 1. Again do the square. If you do the square, you get 4q square plus 4q plus 1. Now see, q was an integer, obviously, since it is a quotient. Q square plus q will be an integer again. Let's take this as an like whole number, and then 1 is the remainder. So this proves my claim. Since I have proved for odd numbers, since I have proved for even numbers, it is complete, because a number can either be even or odd, simply, right? This is 5k plus 4. My mistake. This was 5k plus 4. It was meant to be 5k plus 4. My mistake. Which chapter you start after geometry in IOQM Hindi recorded course? See, like guys, what I'm trying to do in recorded course is that I'm trying to complete the basics thing. So after this, I will be covering set theory, right? 2 lectures of set, 1 lecture of wavy curve, few lectures of then maybe modulus and something, which are basics. And then we will pause the course because of boards, because of multiple things. You have school exams as well. We'll resume the course on 15th of March. From 15th of March, we will start with algebra, proper IOQM algebra. Then we will go with number theory. Then we will go with geometry, proper IOQM geometry, proper IOQM number theory. And then we will go with PNC. Getting my point? Getting my point? This is the broad plan. This is the broad plan. Now let's go. Let's go for the second one. Right? Let's go for the second one. Numbers can be of the form 5q, 5q plus 1, 5q plus 2, 5q plus 3 or 5q plus 4. See, if your divisor is d, then there are d possibilities of remainder, 0, 1, 2, 3 and so on till d minus 1. So, if 5 is my divisor, I will have 5 possibilities. 5 possibilities. Right? Again, A. Let's take n to be 5q. Very simple. N square is 25q square, which essentially means 5 divides n. Right? Or n is of the type 5k, which was asked. B. N is equal to 5q plus 1. N square is 25q square plus 10q plus 1. Now you can see 5, it is divisible by 5. So I can write n equals 5k plus 1. This whole number is divisible by 5. So I can represent it as 5k, 1 is the remainder. Second, n equals 5q plus 2. N square is equal to 25q square plus 20q plus 4, which essentially means that n is 5k plus 4. Similarly, if I have n equals 5q plus 3, then my n will be 5k plus 4, and in the last case, I will get n equal to 5k plus 1. But see, like, this is the proof. This is the formal proof. A question might arise in your mind that, sir, if at all, this divisor is bigger, maybe 7, maybe 9. So then, will we be taking 7, 9 cases? No, we won't be. That is why a very beautiful representation was invented, known as congruence representation. Right? You are getting the need of it, right? This proof is very lengthy. Right? We'll do it later. Right? Nice. Perfect. So, I am going to prove second point with a very different representation. I am going to write n congruent to 0, 1, 2, minus 1, minus 2, mod 5. What do I mean by this? In fact, I will not write like this. I am going to write it as plus minus r. This means that n is of the type 5q plus minus r. Now I am not saying that r is remainder. I am not saying r is remainder. What I'm trying to simply say is that, see, like, let's take the example of 9. Can I write it as 5 times 2 minus 1? I'm not saying 2 is quotient. I'm not saying minus 1 is representation. Remainder. I'm not saying minus 1 is remainder. Please listen to this very, very carefully. I'm not saying 2 is quotient. I'm not saying minus 1 is remainder. Remainder is always non-negative. Remainder is always non-negative. You need to understand this thing. But I can certainly say that 9 can be represented as 5q minus 1, which means 5q minus 1 is equivalent to 5k plus 4, right? Because 9 is also of the type 5k plus 4. So I am saying that every number can be represented as this or this or this. See, this is precisely the point. I have effectively reduced the cases by half. I have effectively reduced the cases by half. Am I making sense? Am I making sense? Please tell me. K and Q are always variables, guys. See, like, you don't have to worry about Q and K. Q and K will take their value. All you need to understand is that Q and K are integers. Why I am saying this? Just write 9 as this. Then your Q will come out to be 2. Write it as this. Your K will come out to be 1. Getting my point? This is the whole idea. This is the whole idea. Okay. Am I making sense, guys? Am I making sense? Am I making sense? Perfect. This is very good. Right? So, now what happens is that, see, like, we are going to write a very simple thing. If n is congruent to r mod d, it implies n square is congruent to r square mod d. What does this mean? What does this mean? That to find the remainder of n square upon division by d, we simply have to square the remainder. There is a very simple proof of it. N is dq plus r. You square it. N square equals d square q square plus 2rqd plus r square. Now, can you see that this number is divisible by d? So I can write it as dq1. q1 is another integer plus r square. So this means that n square is congruent to r square. N square is congruent to r square. Can I say this? Can I say this? Can I say this? Please verify. Please verify. Can I say this? This is the proof of it. This is the proof of this statement. A very important statement. And we are going to use it. We are going to use it. The proof is not complete yet. I have introduced something. I have proved that. So, typically in solutions of RMO, INMO, if you introduce something, for example, I have introduced this thing, then you have to prove it. This is called lemma. This is called lemma. L-E-M-M-A. Right? Lemma is a statement which is made to prove something big. Right? This is lemma. Perfect. Good. So can you write UDAN so that I can move forward? You can simply write UDAN so that I can move forward. Perfect. Perfect. So these were my cases, right? N is congruent to plus minus 1, mod 5, N congruent to plus minus 2, mod 5, right? Can you see this? Now I am going to simply square it. Plus minus 1 square is 1. Is it very eco-friendly? Why do I call it eco-friendly? It will consume less of your page. It will consume less of your ink. That is how. This is one way of mathematicians to give back to society by saving trees. It is an eco-friendly thing, right? It is a very eco-friendly concept. Right? Am I making sense? Please say if I'm making sense. So we remove the negative. See, like upon squaring, negativity is removed. And that is the thing. You should always have belief in you. Like you call it, right? We call it that having self-belief removes any negativity. How? You multiply yourself with yourself, right? Like believing in like oneself. Like if I'm believing in myself, then I'm multiplying myself with my inner soul. So that is how perfect squares are always non-negative, right? Sir, I'm not a brilliant student in mathematics, but I'm passionate and love mathematics. Can you teach the path of IUQM daily routine, or what will I do? Please replace it. I have given you the roadmap. You just have to follow my Telegram channel, and I'll be giving the daily targets on it. Right? Perfect. I think this is done. This is done. But I think we should explore about the congruence a bit more. Right? Yes. Represent in congruence modulo. It is called congruence modulo. Right? Congruence modulo. Right? I am writing D as the dividend and small d as divisor. So for example, in this case, in fact, let's write a table. Let's write a table. Right? So this is D, this is small d, this is representation. For example, if D is dividend, this is 4. So I'll write it as 45 congruent to 1 mod 4. Right? So what do I do with it? What do I do with it? Sir, Kota teachers joining Unacademy. Yes. Yes, we are hiring. We are doing well in Kota. And so we are expanding our footprints. right? So now this is a very interesting point. First of all, 82 can be written as 1 mod 9, okay, but it can, this is correct, but this is also correct. 82 is congruent to 10 mod 9. This is the second representation. This is the second representation. What does this second representation means? 82 and 10 leaves same remainder upon division by 9. Upon division by 9. Right? Upon division by 9. Upon division by 9. Yes, you can get it, Ayush Pandey. Or I can write it as 82 congruent to minus 8 mod 9. That is also okay. In modulars, negative integers are also allowed. Negative integers are also allowed. This is the fun part. Why should positive integers have all the fun? No, negative integers can also have fun, right? 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 Am I making sense? Am I making sense? Can we manipulate to get another divisor? No. That is the benchmark rule. Otherwise, you can do anything. But anything is not allowed. Some things are allowed, keeping the divisor same. See, this is very important. I am keeping the divisor same. Otherwise, 82 will have an entirely different thing. See, like if you change the divisor to 11, 82 becomes 11q plus 5. And it makes absolutely no sense. See, like apples can be compared with apples. What I am trying to say here is that if I have taken mod 9, 1 is congruent to 10, is congruent to minus 8. These three have the same meaning. That is what I am trying to say. Right? Perfect. Perfect. So, now, prove that all perfect cubes are of the type 9q, 9q plus 1 or 9q plus 8. Let's see if you are able to do it. If you are able to do it. Yes. Yash knows it all. That is why he is Yash. Yash means glory. He is a glorified kid. What he is saying, so take 9 equals 3q. This gives me n cube equals 27q cube, or it is 9k. Right? Now, if you take n congruent to 1, right? In fact, let's not take congruent. So this was an NCERT question, and obviously modulo is not involved in NCERT. So we have to give the proof which can be written in NCERT. So it is largely based on algebraic identities. A plus b whole cube is a cube plus b cube, or what should I write, 27q square plus 9q plus 1. So if you carefully see, it is divisible by 9. So this becomes 9k plus 1. Last but not the least, n is 3 cube plus 2. If you cube it, you will get 9k plus 8. Right? 9k plus 8. But what if you were to take, what if you were to do this in terms of congruence? Now this is the challenge with congruence. You will have to take 9 as the divisor, right? You have to take 9 as the divisor. As midway, you cannot change the divisor. So n congruent to 0 mod 9, n congruent to 1 mod 9, and you cannot take plus minus because cube of negative is negative, cube of positive is positive. So I'm not going to write it like this. I'm not going to write it. It will be very lengthy. I'm simply going to do, I'm going to make a table. This is n, this is r, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, right? I think it is visible. Yes. What is r cube? Mod 9. 0, 1, 8, 0. What is 3 cube? 27. 27 is 0 mod 9. 4 cube is 64. 64 is 1 mod 9. 5 is 125. 125 is 8. So this is going to be, so you can see here remainders are 0, 1 and 8 respectively. This is the table which I am going to make. Please write it down. Please write it down, guys. I hope you are understanding these concepts. I hope you are understanding these concepts. Right? Did you not teach the inequalities in IOQM? I believe I have done that. I believe I have done that. Right? Perfect. Perfect. Should we do one more problem? Should we do one more problem? Solve for A, B, C belongs to natural number. A square plus B square equals 8C plus 3. Solve it. This was RMO problem. This was RMO problem. This was RMO problem. It has also come in NTSE stage 2. NTSE, it was a very well known examination, but now it is no more. Have you done it? Have you done it? Yes. So the answer is no solution, but this has to be proved. If the answer is no solution, you cannot simply say, you have to prove it. So a square is 4k or 4k plus 1. B square is 4l or 4l plus 1, right? If you add them, if you see, a square plus b square can be congruent to 0, 1 or 2 mod 4. It cannot be 3 mod 4. It cannot be 3 mod 4, right? And this number 8c plus 3 is congruent to 3 mod 4, which is a clear contradiction. Hence, no solution. Hence, no solution. Right? Hence, no solution. See, like, we are not solving the Delhi paper because we did not get any. Nobody sent the paper to us. If we got the paper, we would have solved it. Right? Just send to me on my Telegram. This is my Telegram. @ Prashant 42 Jain. Prashant 42 Jain. Right? Perfect. Let's move on to the next one. Now we are going to study the concept of HCF and LCM using EDL. Right? What is highest common factor? Highest common factor, it has a very simple definition. HCF of A comma B is represented as simply A comma B is highest divisor which divides A and B. What does this mean? This implies if H is HCF of A and B, then A upon H, B upon H should be equal to 1. This means that HCF of A by H and B by H should be 1. Right? This is the definition of HCF. This is the definition of HCF. The rock. See, like I remember a student named Sanil, but I lost track of you. Where are you now? JEE 2024. IIT BHU, congratulations, man. You got into IIT. Perfect. See, if H is HCF. Now, let me give you an example. You all know that HCF of 42 and 78 is 6. Right? So, just simply divide by 6. Right? These two numbers should be co-prime. Are they co-prime? Yes, they are co-prime. Are they co-prime? Yes, they are co-prime. Getting my point? So we simply write A equals Hindustan Petroleum, B equals headquarters. This implies PQ. This is the official formal statement. This is known as HCF. This is known as HCF. This is known as HCF. This is actually the next lecture also, HCF and LCM. But we are going to clearly write. And P and Q should be natural number. This is a very important point. P and Q have to be natural number. Sir, why are you taking lectures in English? See, like I have given everything to my Hindi audience, right? And I came to know that I have some fans who like study from me in English. So I have decided to make lectures in English. Correct? Perfect. Right? Now, finding HCF using, this is a very important thing, EDL. This is called EDA, Euclid division algorithm. This is called Euclid division algorithm. Right? Now, if you remember, we used to calculate HCF in this manner. So 42 is written here, 78 is written here. You write 42 here, 36. Then you take this here. And once you have 0, this becomes your HCF. So the way to do it is, you start with larger of the two numbers. Let's assume that I have to find divisor of HCF of 78 and 42. So this becomes 42 times 1 plus 36. Then in the next step, you make this as your dividend and your remainder as divisor. Again, in next step, you make this as your dividend, remainder as your divisor. Once you have 0 as your remainder, this becomes your HCF. Right? You have always known this step. This is the way to write it. This is called Euclid division algorithm. Euclid division algorithm. Euclid division algorithm is used to find the HCF of two numbers. Obviously, see, like this is not the effective way to do it. We can write it using this type of table, right? In your younger days, you must have found it like this, right? HCF and LCM, finding HCF and LCM using this table, I don't remember it. But now you are a big guy. You have to prove these things in RMO. And in RMO, these type of things work. Perfect. Got it? This is what I like. This is what I like. This is what I like. Perfect. Now, let's do one thing. This is Euclid division algorithm. Yes. Let AB belongs to two natural numbers. Let AB be two natural numbers such that A plus B equals 90. If AB equals 6, find number of unordered A comma B. You have to find number of unordered A comma B. Now what do I mean by unordered A comma B? So 78 and 12 is one solution. So 12 and 78 cannot be another solution, right? I just want unordered pairs, which means 78 comma 12, value of A equals 78, value of B equals 12. Value of A equals 12, value of B equals 78 should be considered same. They are not distinct. Right? How many? 9 unordered pairs. Let's see. Let's see if what Yash is saying is correct. I think you all should try it. This is the last question which we are going to do. A plus B equals 90. Now we are not going to solve it. Simply not solving like this, because it has 89 solutions, right? You remember we did a lecture on indeterminate equations. We solved it. It has 89 solutions, right? But all the 89 solutions are not acceptable, because additionally we require that HCF should be 6. So A is 6P, B is 6Q, and PQ should be 1. I substitute it here. P plus Q times 6 equals 90. My P plus Q becomes 15. Right? Right? Now, 1 14, 2 12, 3 10, 3 11, 4 10, 5 9, 6 8, 7, just a second, 1 11, 2 13, 3 12, 4 11, my mistake, 5 10, 6 9, 7 8. Since I am not looking for unordered solutions, since I am looking for unordered pairs, I do not have to go further than this. So 1 2 3 4 5 6 7. But there's a problem. If I take this as my this can be taken, in fact, if I take this as my solution, what does this mean? My P is 3, Q is 12. P and Q, the HCF of P and Q has to be 1, no? So this solution is rejected. This is accepted, this is accepted, this is accepted, this is rejected, this is rejected, this is accepted. So I have 1 2 3 4, only 4 solutions. Devil lies in the details. You have to focus on each and every detail. Each and every detail, guys. It should be 4. Do you all get it? Do you all get it? So this was my time, guys. We will follow up on this lecture in the next turn. HCF and LCM is going to be the topic for next lecture. See you on next Monday, the last lecture of this year, and then we'll follow up with the next year. I think we can take the lectures. You can suggest me. I think we can take lectures till 6th, 13th of December. What do you say? We can take lectures till 13th of January, right? After that, we'll not put English lectures. We will again resume by mid of March. This is what my opinion is. I hope you like the video. If you do like it, please do share it. Let's crack it.